Hi, Assalamualaikum warahmatullahi wabarakatuh. Okay, today my team will share to you about metallization in the specific topic CVD process. So, my name is Ainul Huda Binti Muhammad Razikin and my group member is Nurul Syamsina Binti BasarulHisham. So, what is actually the chemical vapor deposition process, or the simplest word is CVD process. Okay, CVD process is a process which is substrate is exposed to one or more volatile precursors which react or decompose on the substrate the surface to produce the desired thin film deposit. Or the other word is CVD is the process precursors react to form a solid coating on a heated substrate. Okay, we will see how the CVD process going on. Okay, so here is the process of CVD. First is electrolytic deposition of wafers is a very similar process to electroplating either metals or material. Or this method first requires the metal source to be connected to a positively charged electrode, while the substrate is placed at a negatively charged electrode. After both the plating material and substrate have been connected to electrodes, they are placed in an electrolytic solution for film deposition. Once both parts are submerged, a DC charge is sent to the anode, which is positively charged electrode, which will oxidize the metal and dissolves it into the solution. What happened to the negative charge? Okay, the negative charge of the substrate will attract positively charged ions in the film to create a uniform film. To ensure cleanliness, this entire process takes place in a clean room, and the plating solution is continuously filtered to prevent unwanted particles from damaging the wafer. Okay, so this is the process of the CVD. We will show you how it's happened in the animation later. So we proceed to the next slide. Sketching coding.
Okay, so next I'll be explaining to you about the coding. So this is the coding on the backdrop. Okay, so when you click on the green flag button, the backdrop will switch to front page. And as you can see here, all the sprites are hidden when the backdrop is at the front page. Okay, so next, if you click on the spacebar, the backdrop will change to park and only two characters will be shown, which is character 1, which is named as Alice, and character 2, which is named as Zach. Okay, so at the park, Alice will walk towards Zach and they will have some conversation. And after 17.7 seconds, the backdrop will change to CVD. In the CVD backdrop, only Zach and Alice will be shown. Here, Zach will explain to Alice the CVD definition, and after 24.8 seconds, the backdrop will change to CVD animation. Okay, here, all the other sprites are being shown except for Alice. Only Alice is being hidden in this slide. The CVD process will be shown in this slide. Okay, so after 101 seconds, as you can see here, the backdrop will be switched to white backdrop, where some more process is shown. Okay, so after Zach finished explaining about all the process, which is about 16 seconds, the backdrop will change back to CVD2. And here, only Zach and Alice will be shown. They will have a conversation for a couple of seconds among them, and the backdrop will be switched to a black backdrop, as you can see here.
Alright, so next we will watch how the process metallization will be present in the animation of the sketching assignment. So let's watch together. Okay, 1, 2, 3.
Hi, Zach.
Hi, Alice.
Have you finished the homework about metallization?
Yes, I've already done it. Why?
I don't really understand that topic. Can you please explain it to me?
Yeah, sure. Come on, follow me. Okay, so first, let me explain the meaning. Metallization is an adding process that deposits metal layer on the wafer surface. There are many ways to do metallization, and one of them is by using the CVD process. CVD, or chemical vapor deposition, is a process where gaseous precursors react to form a solid coating on a heated substrate. Now, let's see how it works. This is called a reaction chamber. First, the wafer is placed on a heated plate inside the chamber. Then, the heated plate is locally heated to the desired reaction temperature, which is in between 200 degrees Celsius and 2200 degrees Celsius. Then, the controlled flow of mixed reactant gases is introduced into the reaction chamber. The occurrence of metal deposition from the metal chloride gas will be shown in this example. The first gas is the metal chloride. The metal is shown as blue atoms and the chlorine as green atoms. The metal is combined with chlorine so that the compound can be maintained as a gas. At the same time, the controlled flow of hydrogen gas is introduced and is shown as red atoms. The process conditions are adjusted so that the mixture won't react until it comes into contact with a solid surface such as the wafer. As some of the gas molecules come into contact with the substrate, they are absorbed onto the wafer surface. They're held onto the surface through relatively weak localized attraction. This adsorption allows the two reactant gas molecules to react together. The chlorine and hydrogen react together, creating hydrogen chloride waste gas, and the metal atoms remain bonded to the component. The waste gas is continuously removed from the chamber using the vacuum, creating a constant flow of reactant gases into the reaction chamber and waste gases out of the reaction chamber. As the coating process initiates, the first deposits are localized. Over time, the whole surface of the substrate becomes covered. The coating will apply to all accessible surfaces, and not just the top surface. We can keep the process going to allow the coating to grow depending on how thick we want it to be.
I see. Now I understand how it works. Thanks, Zach.
You're welcome.
So, it's the end of this sketch video. So it means the end of our presentation. That's all about metallization in CVD process that we can share with you. So thank you for giving your time to hear us. So that's all from us. Thank you.